Hi everyone, and welcome from Cambridge, UK, where we're bringing you this exciting webcast today in partnership with Senko. The webinar will look to provide details on some of the more streamlined alternatives to multi-fibre push-on cassette-based solutions and advise how to future-proof your network for 800G plus deployment. You can also learn how to build topologies with VSFF connectivity and discover how ceramic connectors can coexist or even replace legacy MPO as the connective of choice for 800G plus deployments. My name's Keely and I'll be your host today, and I'm very pleased to be joined by our speakers, Phil Ward, Director of Strategic Marketing at Senko, and Chris Tutt, Product Line Manager at Senko. In terms of format, we'll have a presentation from Phil and Chris, followed by a short Q&A session. Please feel free to submit your questions as they come to you and we'll answer them at the end, so don't feel that you need to wait. So without further ado, let's get started. I'll hand over to Phil. Phil, thank you very much.
Thank you very much, and thank you to everyone that's spent the time to join this webinar. Sorry that we were a bit late starting. Just had a couple of technical issues, as we do in the technical industry that we live and work in. So yeah, thanks, Keely. So we're going to be just going through a brief description of what Senko is, not spending too long because we want to get into the meat of this presentation. We're going to look at some of the MPO-based applications out there at the moment for the higher data rates, some of the drivers for them, some of the challenges that we experience or we know about. And then we're going to look into VSFF alternatives to those MPO-based systems. And this really kind of is triggered by the sudden demand that we've had in 800 gig optics. We all know that we're going through this artificial intelligence rush at the moment. It's certainly something I use on a regular basis. I think the adoption of ChatGPT, for example, to get 1 million subscribers was a matter of days as opposed to a matter of a year or so for Netflix. So everyone knows that AI is driving this, and I don't need to talk too much about it. As a supplier of high quality leading MPO MT based ferrules, Senko's obviously seen this uplift, Keely. So we've experienced increased demand. We're getting great revenue, even though it's a flat period in the industry. So I wouldn't say it's the best time because we've had the energy crisis, we're post-COVID, political instability. So with all that in mind, it's great to have an area of the business that's doing really well. But of course, with that comes some challenges. So what we're doing in this webinar is we're looking at some of the areas where VSFF can help to alleviate some of that demand on MT-based connectivity, and also perhaps lean down the network and make it more efficient. And that's where we'll look at whether it's faster, leaner, denser, or greener at the end. So I'm not controlling the screen, as you would hope to on something like this. Chris is my right-hand man. So Chris, if you would go through to the next screen. So just a bit about Senko. We offer interconnect solutions from the first nanometer to the last mile. And what I mean there is that we have PIC connectivity that goes onto the ASIC itself in co-packaged switches. So that's the first nanometer where data is transmitted. And then we move down the network. So we're involved in transceiver connectivity. That's what we're talking about today, the 800 gig, 400 gig range. We supply the connectors that go inside of those transceivers, and of course, the connectors that are patched to it. Then we have what we call legacy, which is the connectors we've all, built our careers on, the things like the MPO, the LC. And here, Senko add application benefits to connectors. I'm sure you're all aware of our feature-rich connectors that perhaps speed up polarity flipping with LC or refine the MPO somehow by offering gender change or a polarity change or what have you. So that's the legacy area. And then finally, we have the IP connectivity area, which is connectors being deployed in the access environment. So it could be an antenna situation, but could also be a fiber to the home drop. So what you see here is a complete progression of connectivity. Now, where does VSFF fit into this? So if you click through, Chris, you'll see that VSFF is embedded in all of these areas. Because it's a new connector that's smaller and denser than the legacy, we can apply it to lots of different application areas, be it co-packaged switches, be it in the transceivers itself, or be it in IP-rated systems where we can get more connectivity into a standardized housing. So Senko pioneered this technology back in 2016. We're the industry leader, and we have a wealth of patents surrounding it. So without further ado, let's move on. So some of the MPO-based applications, let's look at the transceivers first of all. So currently with 800 gig, we have two main MPO types. We have the 2x DR4, which is two MPO8s in a single transceiver, and we have the 1x DR8, which is a 16-fiber MPO into a single transceiver, so one connector, 16 fibers. But we also have this LC-based system, which we call the belly-to-belly arrangement, and this is where you have the connectors sort of belly-to-belly in the transceiver. It's as simple as that, two connectors per transceiver. Now, if we look at the 2x DR4, that was developed so that you had backwards compatibility or interoperability with 400 gig systems. So anyone upgrading their existing MPO-based transceivers with 400 gig could deploy an 800 gig transceiver and then branch out to those 400 gigs. So it's backwards compatible. On the 16 side, you've just got a single interface. So you could break out 16 into more pairs of fibers if you wanted to aggregate those data rates, or if you wanted to lean down your network, you could just patch transceiver to transceiver. Now, we work with the MSAs. This footprint, the QSFP DD footprint with the latch on it, the pull tab, restricts the space keyly. So we've got this refined connector footprint that fits into this window. And we've also enhanced the accessibility of that connector because the switches are getting so dense. You know, you're getting 32 ports on a switch. You've got two MPOs per transceiver. It's getting very hard to access. So Senko developed this easy range of connectors to improve the space, but also to improve the access to those connectors. So drivers for this, MPOs used the world over. It's a very popular choice. It's a high fiber count cable. It allows you to break out those data rates to lower data rates somewhere in your network. And that's the key about these parallel MPO interfaces, is that you've got the chance to aggregate and break out. With an LC-based system, you don't get that same degree of flexibility, especially with a WDM interface as opposed to a parallel interface. So Chris, if you wouldn't mind. So that easy way pullable solution works at the transceiver level, optimizing 800 gig, but it also works if you want to patch to transceivers. So if you've got an MPO patch panel that is connecting to those pieces of equipment, then a pullable boot is greatly enhancing that experience. And of course, you get that functionality with all of the leading performance that we have, the gender change, and the various benefits you get with the Senko MPO. So, Chris, just a comment on this. When we talk about demand for MT ferrules, we're talking about low loss, super low loss ferrules, Keely, because that's what's required in these 400 gig, 800 gig optics. And this is where Senko is excelling, because we have an exceptional performance when we do a random mating test. So a lot of people claim they have a very good performance when going against a master reference cord. But when you actually mate, randomly mate connectors together, you see with a lot of the lower cost products coming in from China that they don't match their own performance standard. So if you look at this table, a histogram, you see the blue line is Senko, the Senko product, which is way below the sort of 0.1 dB level in insertion loss. We recommend 0.35 as a max, but on a mated random testing, you can see that we're actually achieving 0.1 dB as a kind of standard. On the other hand, if you look at the green histogram, that's our competitor, a next best competitor that's a leading brand. They have a much lower frequency of connectors that are reaching that low loss performance. And even when we mate our connectors to theirs, you can see that the purple line, I think it's purple, is still significantly better. So this is where Senko is differentiating ourselves in the high performance, low loss market. And I advise everyone to check random mating rather than, reference tests in this area. Okay. Now, MPO is not just used on the transceiver, of course, it's used in the backbone structured cabling of networks. And this image is a very basic, simplified view of it. But what you have on the left-hand side is, a MPO backbone trunk plugging into the rear of a cassette, which will be another MPO interface, a Hydra assembly in that cassette, and then LC adapters on the front. And of course, that gives us the patching interface to LC-based transceivers. So whenever you've got a base 2 type infrastructure, a duplex LC is a pretty good way of doing it. If you look at the two cassettes in the middle, this is what we call a cross-connect area that's managing those connections at different ends of the network and consolidating it into an easily accessible area, generally using cassettes. And then on the right-hand side of this graphic, you see an MPO adapter plate connecting to MPO-based transceivers, which could be a 1x16 or it could be the 2/8 that I just talked about. So MPO has been a very important building block for data rates of all kinds running from 10 to 40 to 100 to 400 to 800. But with it, there has been some teething problems, I would say, over the years. I've built a lot of product families with MPO. I know about the problems that people experience. And one of those problems is contamination. So the ferrule on an MPO is much bigger than a ceramic-based ferrule. So any dust or dirt that gets onto that ferrule surface has a bigger impact on the overall loss. Another issue with MPO is the wide variety of options you have. For example, we've got an 8, we've got a 12, we've got a 16, we've got a 24, we've got a 32, we've got a male, we've got a female, we've got a type A, type B, type C. There has been a whole periphery of different types that adds some confusion when building an MPO network. Now, these days, it's got a bit easier because we've refined that and people aren't using so many variants. We're concentrating on 12 and 16 pretty much as our focus for 400 gig and 800 gig. But you can see here that building with an MPO backbone gives you that flexibility for MPO transceivers at one end or base 2 transceivers at the other end. And that cross-connect, that ability to migrate data lanes and shuffle in the middle of the network is very important. Chris. Okay, Chris, I think you're going to just introduce the connectors, right?
Yeah, so I'm going to talk a little bit about the VSFF technologies. So the SN connector really can be utilized in transceivers. So going from an LC when you're getting 2 connectors or 2 fibers, with an SN, you can get up to 4, so you can get that individual breakout on the transceivers. Now, the thing about the SN is it is using the 125 ceramic ferrules that are used in LC connectors. So you're getting the commonality and the known optical performance of an LC, which is the largest fiber product in the world, using that same ferrule in the SN to give you the same optical performance. You get some other features with the connector. You get the direct breakout capability by having that in there. And then you can create the transceiver shuffling with the SN connector. Other features that you might see would be polarity swappable. The adapters, you can use standardized panel cutouts. So the typical cassettes that Phil was talking about where the LC is used, SN has a similar adapter footprints. So where a quad LC was getting 4 connect fibers, now that same panel or same cassette can use an SN adapter that gets you 8 fibers. So you're doubling the density without even changing the cassettes, other than changing the adapters. It's a pullable boot, so much easier to connect and extract. Other features in our adapters, you have shuttered and non-shuttered solutions. Well,
don't steal my show because you're talking about the benefits I'm going to come up to in a moment. So
yeah. And then some other simplifications that we'll see and we'll talk about is a backbone trunk optimization using a uniboot. So where right now you would be typically using an MPO on the back of a trunk, now you can have the separate individual connectors on the front panel and then go into a uniboot all under one jacket, 8 fibers under one jacket on the back of the trunk. And then to even more densification on the interconnect, the inter-data connect data center trunk optimization with our SN-MT. So this is an MT Ferrule-based connector, same footprint as the SN, but you're getting an MT-based or 16 fiber per connector on that back panel. So the trunking from building to building, you can save a lot of space. Other places that we'll talk about is the CPO switch density, where you can get more fibers and leave more room on your CPO switch.
Okay, let's go into those applications. So this is the first one that Chris was talking about. Is the SN was developed for the transceiver deployment before it ever became a patch panel product. So we wanted to fit more duplex connectors into a single interface. Previously, LC was the only single interface that was possible, but back in 2016, there was a drive to get multiple connectors into a transceiver so that we could directly break out from that transceiver into multiple data lanes. So one 400 gig transceiver would become 4 100 gig transceivers. And that would allow the spine leaf architecture to grow much wider than it could if you just had one-to-one relationship with a transceiver. And that's part of the unified mesh approach of data centers, is to connect everything to everything. So if you can break a transceiver down into multiple lanes, then you're having more flexibility, more scalability, more granularity across your network. And the big point about the direct breakout, which is a patented area of Senko's, is that you don't need to use cassettes and you don't need to use fan outs. With an MPO system, one of the challenges is that you can break out, that's true, but you need to have some kind of device for doing it. And that's either a fan-out cable or it's a cassette-based system. And whenever you've got that additional hardware, you've got complexity, you've got cost, you've got additional mated pairs and such like. So that was the driver for this technology, and it allowed switches to become denser. So a 32-port switch could then become a 128-port switch when it's broken out at a lower data rate. So high radix switches can operate at different data rates. And that was really the key reason for developing the SN. Now we have a 400 gig QSFP DD footprint and OSFP as well. We work very closely with the MSAs. But we also have in the MSA an 800 gig transceiver developed, which allows 8 pairs of SNs to be broken out. So that would be an equivalent to the MPO 16 variety that we looked at the beginning. And the one above the switch here on the graphic would be the equivalent to a 400 gig DR4 type transceiver. Okay, so next slide. So not only is it important to break out aggregated lanes, but it's also important to shuffle them. So spine leaf architecture is about, as I said, connecting as many pieces of equipment to each other, right, in a mesh topology. So with this ability to break out 4 lanes, you can connect effectively to 4 pieces of equipment. Okay, so that's what we call the shuffle approach, where you're shuffling lanes across multiple other transceivers. Now, in reality, these transceivers are not going to be that close together. You might have a scenario where it's top of rack, or you might have middle of row in a cluster, which is a reasonable short distance. But in theory, this graphic is a bit misleading because you don't always have that very close proximity. So it's really subject to every application and how you would deploy that shuffle. Okay, Chris. So if we look at how we've looked at how SN can increase the densification of a switch. Obviously, that's a burning desire for the hyperscalers or anyone that's having to power these switches to cool them down and reduce their total cost of ownership. But in the structured cabling world, we also want to improve the efficiency of our real estate. So moving away from an LC-based system to an SN allows us to fit more connectivity into a smaller space. Now, obviously, that has sustainability benefits. Keely, we did an article about sustainability some time ago, and this is connected to that. It's the idea that by reducing the footprint, we reduce the amount of rack space, we become more efficient, the data center is optimized, and subsequently it becomes more sustainable because we're not investing in so much plastic and steel and all these sorts of things. But from a total cost of ownership perspective, there's a big buy-in for the people that we support with connectivity and their customers, because everyone wants to fit more into a smaller space. Now, with SN, you still get that duplex ability, so you can connect an SN to an LC transceiver. That's relatively easy. It's one jumper. But with the SN, you can double the density of the LC. So you can take a 12-fiber LC to a 24-fiber SN if you just want to double your density. And if you want to treble your density, you can also do that. We have adapters that allow that kind of densification, subject to what sort of hardware you're using, that will give you 3 times a denser infrastructure than you had before. So that has to be the best and densest way of connecting base 2 connectivity. And base 2 is used in many areas of the network, but predominantly it will be on the server end of the link, where you've got lower data rates running across, let's say, LC transceivers. You can go back still, Chris, one slide. And then on the other end of the network, you've got the MPO-based connectivity, which of course plugs into your MPO 800 gig or 400 gig transceivers. But the important thing about this is that you still benefit from having duplex cross connects within the center of the link. So somewhere you still want to have an area for aggregating those data lanes, and that's what we would call a cross connect, or there's other terms for it, but that's my terminology. It's a centralized cross connect. Okay. So we see a densification that we never had before. LC has the ability to reach a benchmark density of 144 fibers, that's 72 channels. And that can be done with a cassette-based system, or it can be done with a patch panel. Cassettes are preferred because, of course, they give you better access. You can slide out a cassette, you get finger access to the individual LCs. But you could do the same thing with patch panels. There's companies that we work with, very big infrastructure suppliers, that have transitioned away from cassettes in some regards because they have they're trying to apply their product to the spine leaf architecture in a slightly different way. So we're already seeing a transition away from cassettes. But beyond 144 fibers, it's not possible to get that density. So SN gives you 3 times the amount of density in a single 1RU panel, and that density is 432 fibers or 216 channels. So that's 216 transceivers that you're going to be connecting if it's an LC-based infrastructure. Okay. And this is an example of what I mean about the centralized cross-connect and the shuffling of data lanes. So you could shuffle them at the transceiver level, like I showed earlier, but actually most companies want to have some kind of structured approach, which means some kind of backbone cabling and hardware to manage the different relationships with their transceivers and equipment. And here you can see that even though we're running high data rate MPO optics at each end of the link, we're still consolidating and shuffling those in one centralized area. And what better choice to take than an SN when you're centralizing connectivity, because you want to get the maximum densification in those areas. We don't want to be having numerous racks to try and manage cabling of a cross-connect nature, because then you've got to run cables between racks, and that's not preferable. So densification is really key in those areas. Okay. So on that note, we're going to ask a few questions, Chris, right? What's the first question we've got?
Yeah, so the first poll question, if you guys can answer these. So where do you see the most application for duplex SN, or very small form factor connectivity, in your network infrastructure? Is it increasing the patch panel density to duplex-based transceivers in a centralized patching area to manage or shuffle lanes of data between equipment, or you don't see any relevant application for SN connectivity currently? So If you can answer that, that would be appreciated.
I think the polls, you're going to get all of the polls at once. There's 3 questions, and I think you'll see all of them, even though we're phasing them in during the course of this slideshow. So don't worry about that. You can either answer all of them now, or you can come back and answer the second one when it comes up, which won't be too long. Thanks.
Thank you.
Okay, so we're gonna take a look now. We've looked at SN as a single duplex connector. We're now going to look at SN Uniboot, which is a kind of special hybrid variant. This is an 8-fiber connector, so it's got 8 ceramic ferrules, but it's made up of 4 duplex connectors ganged together. So that gives you a very unique proposition where you've got an 8 or a 2-fiber connector. So that direct breakout capability I mentioned at the transceiver, where you can split out lanes of fibers, you can do the same thing at an adapter level, where without the need to have an MPO to an LC cassette. So this gives a carrier grade ceramic-based base 8-fiber connector that could be an equivalent to an MPO. So, and how's that deployed? Let's have a look at that. So if you look at the current infrastructure, I mentioned that MPO is used largely in the backbone, but what that does is it gives you that additional mated pair at every flexibility point across your network. And we all want flexibility. We want as many access points as we can possibly get without increasing the optical budget beyond what's allowable for the particular data rate that we're running or the particular reach that we're trying to send that transmission over. So even though we want to add cassettes, there is an impact, and potentially you could have bit errors because you've gone over the threshold of what the system will allow. Now, with SN Uniboot in contrast, you have this base 8, base 2 flexibility directly at the patch panel. That means you can connect an 8-fiber connector to it, or you can connect multiple 2-fiber connectors. And that gives you unbelievable flexibility without having that additional mated pair. Why is it important? Well, we know that higher performance optics is required for these higher data rates, the longer reach. Ceramics is the world's most popular chosen ferrule type. We know that it's not impacted as greatly by dirt and dust and ingress. The losses can be significantly lower, so you could be talking 0.15 dB instead of 0.35 dB over an MPO. The fact you've only got 1 connector instead of 2 means there's no accumulation of that loss across that access point. So what you're getting is more flexibility, but less impact and a leaner link design. And that's really where we're coming at with this. It's about sustainability. It's about efficiency, building the same flexibility with less. That's the idea of that. Okay. And of course, less cassettes means less plastic, less hardware, and all those things. This is what it looks like in a panel environment. So on the left-hand side, you see the traditional cassette-based systems. In this case, it's a base 8 approach with an MPO coming in the back, 4 LC duplex on the front. That's pretty much data center 101. Most people are familiar with this. But on the right-hand side, we've eliminated the cassette. We've replaced it with an adapter, which is a 4-port adapter. You can plug in a Uniboot connector into the rear with 1 cable, as Chris mentioned, but you get that flexibility to go to LC-based systems or SN-based transceivers, or you have the ability to use 8 fibers and then plug to an 8-fiber transceiver. So you get that mix and match flexibility. But important is you're not losing any density. So even though you're adding flexibility, you're increasing the density by a factor of 3, as I mentioned earlier. So it's a really, what should I say, compelling argument to use this product. Okay, thank you, Chris.
All right. Poll question number 2. So what do you see the biggest benefit of using the SN Uniboot connector in the network? Is it reduced footprint and increased density compared to the traditional connectors, improved reliability and performance versus MPO and high-speed data transmission, or ability to eliminate the cassette and still achieve a base 8 or base 2 flexibility? If you could answer those questions, that would be great.
Thank you.
Yep.
Okay, so now we're going to move over to possibly the most relevant connector in terms of higher data rate optics currently, and that's the SN-MT. As Chris mentioned, this is a equivalent of an MPO. It's got a kind of MT ferrule in it, but it's a much thinner, more compact ferrule, because this connector is 2.7 times smaller than an MPO. So it's delivering the same fiber count, but it's reducing the footprint of that connector. And not only is it reducing the footprint, but it's also offering the ability to gang those connectors together. So we offer this as a 16, a 24, and possibly it's just around the corner, a 32 fiber variant of this, which gives you massive densification at the connector level, but then the ability to gang them together gives you even higher levels of fiber count per connector. So 416s would be 64, 424s would be 96, 432s, I don't even know what that is, 128 fibers in one connector. And why is this relevant? Well, because the hyperscalers want to patch as many fibers in as they can with the smallest possible footprint that they can deliver, whether it's across a trunk or whether it's across a patch panel. And we're going to look at 3 of those examples, first one being inter-DC trunks. So what's happening is that data centers are being interconnected with high density rollable ribbon cables, anything up to sort of 6,912 fibers. And this is 200 micron rollable ribbon. It's produced in a cable which is tiny. It's about, I don't know, between 10 and 20 millimeters, depending on vendor. It has revolutionized the hyperscale data center market, not just hyperscale, it's used across the world in fiber to the home deployments as well because of the size of the cable. Now, splicing ribbon fiber takes a lot of time. You've got to have trained technicians with the right equipment. You've got to have the time, the project window to be able to strip those cables, clean them, re-sleeve them, dress them into a rack, load them into a patch panel, splice them to pigtails. It takes an awful long time. It's a very low loss method of doing it. And I don't have any criticism of technicians and splicers the world over. I love them. I think they're great. But I'm just saying that we don't have the time to deploy it. So what's happening is we're seeing companies with the expertise, and there aren't that many of them, factory terminating these high density connectors onto these rollable ribbon cables to produce what is a multiple thousand fiber plug and play cable system. Very difficult to produce, very difficult to install, and but the benefits are it reduces the installation time substantially, and you can just plug and play. Now, the connectors that are being used for this are, of course, the MPO. The MPO 24 is a popular choice because it's very high density. So you don't need so many connectors on your trunk to deliver that number of fibers. But the problem is with 24, it's not the ideal fiber count for 400 gig or 800 gig. We know that 8 and 16 are preferred. So you do have a bit of an issue matching that connector to your infrastructure when you get it there, right? The other thing, as I said, is the MPO is quite large. So if you can move to a smaller footprint, it's better. And you might see some vendors advertising this kind of disassembled product where you install the ferrule of the connector, and then when you get it to the other end, you add the housing and you finish the job off. That's not something we endorse, because whenever you've got assembly of products in the field, there's a chance that things break. You could have performance issues. So with the SN-MT, in contrast, you get a full assembled connector that's 2.7 times smaller, that could be individually supplied or ganged in 2 or 4. So you can reduce the amount of cables on your system. You can reduce the amount of stagger lengths, making the whole system more optimized and easier to deploy. One of the issues with this is that you get long tail lengths on your cables, and then you've got to store them in some kind of rack when you get to the patch panel at the other end. So we're trying to reduce that complexity. Next slide. So when you do get that SN-MT to your other end, your cluster or your demarcation point in the building, when you're going to transition from there to the internal network, you want to get as many fibers into a patch panel as possible. And with the SN-MT, you have the ability to fit 54 4-port adapters, giving you 216 ports. and that is a fiber count of 3,456 fibers with a 16 fiber ferrule. Okay, you could move that to a 32 fiber ferrule, and that will give you 6,900 and something, and I don't remember the number, so I apologize for that. But what this allows you to do is have one trunk connecting to one patch panel, and you get much better rack efficiency when you get it there, okay? So once you've got that 16 fiber footprint, you can then patch to 16 fiber transceivers, or at least you've got the ability to transition to the right fiber count for your transceiver deployments. So 16 seems to be a bit of a sweet spot at the moment, and I think 32 is going to be a more compelling argument because of the density. So we've never experienced a situation where people say they don't want a higher denser connector. That's never happened. So I think that we'll always find ways of branching cables to a higher density connector than we'd have people saying, no, I don't want to go to it. I'll stick with the 16. So I don't see that happening. Okay, so, and then finally, SN-MT is being used on co-packaged optics switches. So we're heavily involved in connectivity to the ASIC inside of these switches with our MPC metallic PIC connectors, but it's the faceplate that is impacted most of all by MPO connectivity. In this particular example, it's a 51.2 terabit switch. You can see that the MPO takes up a considerable real estate versus the SN-MT. And what we find is that people want to utilize that real estate for things like external laser sources, hot swappable laser sources that can be easily removed without having to get access inside the switch. So even though SN-MT 16 is a shift away from the kind of known MPO 8 that many customers love, it still achieves the functionality which is required to produce these high data rate switches. And also we're seeing this connectivity in the midboard, and we're also working on systems for the backplane. But with the new products that we're developing for the switch connections, we're looking to eliminate some of those midboard connections. I don't want to give too much away because we're launching a new product at OFC in a week or so. It's coming around quickly. Okay.
All right, question number 3. Which SN-MT fiber count do you consider to be the best choice to support current and future developments of high data rate optics, including 800G? Base 8, base 16, base 24, or base 32? If you could answer those, thank you.
Thank you, Chris. Okay, now we're coming to the end now, so I just want to summarize what we've been saying. So if you just click through, Chris.
Yep.
So we want to make things that are faster, leaner, denser, greener. That's kind of the philosophy of Senko when we develop connectors. But this applies to the whole network. So if we can produce this high density connectivity that can be quickly installed and serviced, and it's leaner, so we don't need so many connectors in the network, that is going to have a knock-on effect with sustainability. So that's the end goal, but it's a byproduct of doing these different things, right? So what we've said in the course of this webinar is that SN offers triple density of base 2 connectivity when patching to base 2 transceivers. So there we've got, it's leaner, it's denser, and it's faster to install because we've got one panel instead of 3 panels. So it's very easy to do the maths and do a calculation to work out how it saves not only the installation time, but the operational time of the network. Okay. We also looked at the SN and how it allows consolidation and cross-connectivity of fiber lanes. So even if you're using MPO-based transceivers on one end and you're using SN or LC on the other end, having that centralized patching area where you can manage and shuffle the lanes is still a requirement. That's not going away. So SN, with its high density, easy access, and the ability to use an 8 fiber or 2 fiber is an excellent solution in those environments to manage that variance in connectivity at the equipment. Okay, then we looked at the SN Uniboot and how that offers a high performance base 8, base 2 hybrid alternative to MPO. So a carrier grade solution for server connections, So you can use it at the back of patch panels to servers, and also in this centralized shuffling area. And really the benefit of that was the, one cable, not 8, and the ability to patch 4 times faster. That's a real crucial point. And hyperscalers are coming to us and saying, look, I love this density, but how can I speed up the patching time, either behind the back of the panel or to the front of the panel? And this is something you don't normally think about, but the hyperscalers, with all of these multiple thousands of connections and these narrow project windows, they're starting to get interested in every process along the chain. So next, we looked at the SN-MT, I believe, and we looked at how that provides a 2.7 times denser alternative to MPO. For DC interconnects, so this ability to connect with rollable ribbon, plug and play, factory-made trunks to the cluster areas within data centers, and also the patch panel densification once you terminate that connector. And it doesn't necessarily need to be a cassette, could be a simple engineered patch panel, or it could be a unique, customized, dedicated product, as some of the companies we work with, the big players, have started to produce. So there's many variants and flavors out there at the moment, but the SN-MT is the preferred delivery method. Right, next. I think that might be it. It is. Chris, do you want to explain what this means?
Yeah, so I just want to follow up and finish with letting everybody know. So the connectivity that Phil and I have talked about today, there's a very large ecosystem of companies that are either transceiver manufacturers, patch panel solution providers, test equipment, polishing companies that have all made product or have gotten themselves in the position where they can supply product using this interconnect. So these are, just a handful of some of the companies that are ready to go today to show that the ecosystem is ready for deployment.
Yeah, and just to say, these are broken down by company types. So you've got licensee partners that produce the SN themselves, like, for example, AFL or CommScope. You've got partners that implement this into their infrastructure solutions, like let's say Panduit or Huber and Sooner. I see that they're on the call, or R&M or Panduit, for example, that take that connectivity and enable a solution from it. We've then got partners on the test and measurement side, like VRV, and we've got Exfo, for example, and Sumix and people like that. But we've also got partners on the, the transceiver side. There's a number of companies here supporting these products within transceiver interfaces, and they're constantly working with us to develop the next standard. So I hope that gives you a kind of summary of all the companies. I don't want to name every single one of them, but over the course of the next few weeks and months, we'll probably be doing a showcase of these companies so that we can get into a bit more detail. And just finally, before we close off the call and hand back to Keely, I'd like to just say to people that we'll be attending at OFC in San Diego Conference Center, between the 26th and the 28th of March. Come and see us there and experience and explore these solutions for yourselves. We've got real product there. We've got the experts there. Come and meet them and challenge us, challenge Senko with a problem that you're experiencing in your network, and we'd love to solve it. That's one thing that Senko really likes to do, is solve problems. So we'd like to see you there. Okay, Keely, I think we're done.
Thank you very much. Thanks, Phil and Chris. That was really, really interesting. It was some really good content and some really great solutions out there for people to keep their eye on. We're about to hand over to the Q&A in a minute, and there are a few questions that we've had come in. If yours doesn't get answered, please don't worry. We will pass them on to the guys at Senko, and they can answer them for you later on. Actually, one of the questions I was going to ask, you've kind of answered for me in terms of OFC and working with all your partners. Senko's also on the interoperability demonstration with the OIF. I was going to ask about the importance of interoperability, but you've kind of answered that for me already.
Yeah, we've got a few products being showcased there. The the MPC connector, the metallic pit connector, is one of those, which is really a game changer, Keely, because, you know, we're talking about ceramic and MPO-based connectivity. That's okay beyond the switch. But what's really driving sustainability is the ability to bring fiber to the chip, because it's lower latency, it's, you know, it's higher data rates. It's a game changer. So we're really excited about that in particular.
Fantastic. So we've had a question come in asking if you have plans to launch 8-fiber compact adapter.
So I'll answer that one. So we don't have that one specifically. I mean, the compact adapter is typically designed for a cassette, where it's a low profile cassette, to get the max fiber density in that. And right now we have either a 3 or a 6 to a, say, an LC duplex or quad cutout. To do an 8, we definitely could. I would want to just discuss more with somebody, with the customer, what their ultimate goal is for needing that fiber count on that adapter type, and whether or not we move forward. But easily enough could do that.
That makes sense.
Sorry, Keith, just to stress what Chris was saying there, is that the 3-port and the 6-port, they're based on the current footprint size that we're allowed to fit into. So that's what's driving the ability to make that connector now, that adapter, sorry. If somebody's got a customized piece of hardware that they want to they want to take that 8-port adapter and drive it into a system, then we'd be more than happy to do that. And we do work with certain vendors on making specific adapters that fit into their system approach. Because not everyone has the traditional cassette. Some people they've broken away from it, and therefore they're happy to use a non-standardized SC footprint, for example. So, yeah, that's it.
Lovely. Thank you very much. We've had another question. What's the reflectance of the SN connector in SMF?
Yeah, so a typical SN random mating insertion loss for just using our standard premium ferrule that comes with all our SNs would be 0.08 dB using just a standard premium ferrule. Can get even better with our low loss ferrule, but that would be a common number, and that's random mating numbers.
Okay, brilliant. Thank you. And another question, are transceivers with an SN-MT available?
So with the standard SN, there is numerous manufacturers producing transceivers for the standard SN with the LC-based ferrule. The SN-MT, they are in development, a few companies. They're not, I don't believe, producing. Maybe at OFC we'll see some. But I don't think they're readily available yet.
Yeah, currently we haven't got to that stage where the SN-MT at the transceiver is really demanded. You know, MPO is coping quite well. When the data rates go up, you know, when we get to sort of 1.6, 3.2, and we start to see connectors like our PIC connector in the transceiver widespread, then potentially there's benefits in having the SN-MT on the interface. Certainly the size of it is advantageous over an MPO, but currently we're not in that space where SN-MT is really required at the transceiver level. So possible.
We're seeing it more at the switch. So the switches are important, starting to incorporate the SN-MT into the switches on the faceplates.
Yeah.
Okay, brilliant. Thank you. Thanks, guys. So we're starting to run out of time now. So thank you for your questions. As I say, you know, any further questions, we'll send them on to Phil and Chris, and they can answer them for you. Personally, I'd like to say I'm quite excited to hear what's coming up from you guys at OFC. So obviously, continue keeping us posted on that. Just to let you know that this webcast will remain on the Fiber Systems website for the next 12 months on demand, and that's www.fiber-systems.com. So spread the word if you've enjoyed it and you want to let other people know, but obviously let them know that the live Q&A won't be available. So all that remains for me to do now is to thank Phil and Chris, and to thank our sponsor Senko for this webcast. Thanks ever so much, you guys, for joining in. It's been really, really, really brilliant. Also to thank the Europa Science production team for working hard in the background to make this happen. And to thank everybody who's joined us today for watching. Thank you very much. Goodbye.
Great, thank you.
Thank you. Take care, guys. Bye.